All right, now we are going to get Triggy with it and look at U substitution with trig integrals. Now really, there are three integrals that you just need to know to do these. The integral of cosine of x is sine of x, because if we take the derivative of sine, we get cosine. The integral of sine of x is negative cosine of x. So like if we took the integral of cosine, we get negative sine. So therefore the derivative of negative cosine would be positive sine. And then the integral of e to the x is itself, because the derivative of e to the x is itself. So on this first example, what I would choose as my u would lie in the exponent. So I'm just going to kind of highlight what I'm going to choose as my u. So my u would be cosine of x. And my du, the derivative of that, well, remember the derivative of cosine would be negative sine of x. And we pretty much have in this case almost, when we take the derivative, we just add that dx as well. But we pretty much almost have sine of x dx, negative of that. We have the positive sine x dx on the outside. So we could actually say here that the negative version of this, if we just put a negative sign in front of the integral, we could kind of adjust for the fact that our du has that negative sine x dx. So I could actually immediately write this into a u type of integral problem. So in fact, we'll do that. So I have the integral of e to the u, and then the negative sine x dx. Well, sine of x dx would be like negative du. But if I wanted to fix that problem, take that negative sign, I could just move it outside. And then the integral of e to the u is just e to the u plus c. Put a negative out in front. So I get the integral of e to the u, that's just being e to the u, put the negative sign in front. And I'm going to put in, for my u, the cosine of x. Plus c. All right, the next one, I'm going to be intentional about getting my u again. Kind of look inside of a parentheses is where my u could go. And I'm going to say that u, in this case, is equal to 2x plus 1. And then my du is equal to 2 dx. And if I want to get dx by itself, I could say that dx is equal to 1/2 du. So if I'm kind of writing this integral in terms of u, I would say that this is the integral of cosine of u. And then my dx is 1/2 du. And I'm going to move that 1/2 outside. This would just be half of the integral of cosine of u du. And the integral of cosine u du is just sine of u. Plus c. And I'm just going to put in, for my u, what I originally had for my u, which was 2x plus 1. And then that is my complete final answer. There's a few more examples here that I put on the notes. So this is a simplify versus a U substitution. So sometimes I may throw in a homework problem like the one on the right, where one may think, oh, there's E, I need to do a U substitution, but this is actually a lot easier to just break into two simple integrals. So on this one, I would just say e to the x dx plus the integral of 3 dx. And we know that the integral of e to the x is itself. And then the integral of 3 would just be 3x. And there's technically plus c on both of them, but we could just kind of factor that plus c in at the end and know that we're adding a constant. Now, you can kind of see side by side. The other one, kind of does need a u substitution because you got a denominator, numerator type of setup, and you got an e. So we'd want to maybe think about for this one what our best guess would be for the u. And I like choosing the more complicated expression for the u, so I'd choose the denominator route. And when I'm doing that, I'm going to write that u is equal to 3 plus e to the x. And du, well, the derivative of e to the x is just e to the x. And if I'm writing the integral expression in terms of u, well, in the numerator I have a du, because I have an e to x dx, that becomes du. And then in the denominator I just have a u. This is just the integral of 1 over u du. And it turns out that the integral of 1 over u is the natural log of the absolute value of u. And this is always the case, that the integral of 1 over u is the natural log of the absolute value of u, kind of as a nice integral like that e integral. Then you add a plus c, and we do need to kind of factor in that the u was 3 plus e to the x. Add that plus c at the end, and we have it completely integrated. So the u substitutions are really nice, powerful tools for both exponential and logarithmic functions. Actually, you hear a lot in the news right now about logarithmic functions and exponential functions with the spread of the coronavirus. So if you wanted to take areas under the curves, you'd actually probably have to do some u substitutions in some of those exponential functions. So anyways, I hope that you found these u substitution to be a nice tool, and that you get some good practice tonight with them, with the assorted problems that I'll be assigning you. Thank you very much for listening today, and enjoy your week.